Good afternoon, good evening, everyone, and welcome to this class. In today's lecture, probably in all probability, we should be able to wind up this topic of refraction. There are two or three small things left that we'll try to cover in this class. If you remember what was the topic of the last class, I think the
A
last thing that we discussed,
combination of lenses with the mirror.
combination of lenses with the mirror. So once I have lens combining with a mirror, we had seen that the ray gets refracted two times, once while going in, then the other while going out. So we had seen the different types of combination that we can have, and we had seen how to find out the focal length for these combinations. Yes or no? Now once you get the focal length for this combination, this becomes a simple question of mirror. Do we understand this? Yes or no? So
Yes,
just
sir.
to check whether we have understood the concept or not, I will give you a question and I hope that all of the students would be able to solve it. The question also asks to draw the ray diagram, which you don't have to draw, so we can leave that part because that will not come. So leaving that part of drawing the sketch diagram, the rest of the part are important for us to log this topic once and forever. This is the topic that confuses a lot of students and they do a lot of simple mistakes. I hope you are not going to do this. So this is a problem which is going to test everything that we have studied till now in the last 3 or 4 classes. So the question goes like this: the radius of curvature of a plano-convex lens. So understand, plano-convex, radius of curvature of a plano-convex lens is 12 centimeter and the refractive index is 3.5. So that is the first test. Find the focal length of this lens. The plane surface of this lens is now silvered. At what distance from the lens will the parallel ray incident on the convex face emerge? Sketch the ray diagram. You don't have to do it. Sketch the ray diagram. Leave that part. Find calculate the image distance when the object is placed at a distance of 20 centimeters from the lens. That is the part that is important. So you have part number A, part number B, part number C is not to be done, and part number D. It will test everything that we have known so far about this. Let's see if you can do it. Trust me, it's very simple. If you can't do this one, then I'll give the same question in different parts. But I would be very happy if you can do this on your own. Your time starts now. Remember, I always keep on telling you, bacha, the result is not important, the answer is not important. The important part is that you are trying the question. Remember, JEE is not cleared in the examination hall, it is cleared right now. The same question can come in your JEE, trust me. 2 minutes you have. Best of luck.
Sir, focal length is plus 24 centimeters.
Focal length is plus 24. Okay, try it again. Probably you have made a simple. Okay, yes, focal length of the lens is 24. Right, right. Correct. Sorry. I thought you are giving your second answer. Sorry. Focal length of the first lens is 24. Correct. First part is correct. I thought that the first part has a silver part. Yes, focal length of the lens is 24. Correct. What about the second one? Try it. I will tell you the solution for the first part if you have done. So basically what I have is this. I have a plano convex lens, so I can draw it like this. The radius of curvature of this side is 12 centimeters. I can find the focal length of this lens using the formula. I can straight away use the formula of plano convex lens. I can use r upon mu minus 1. Did I tell you that formula? Yes or no?
Yes, sir.
Just with the formula, I don't have to use this bigger thing. So as soon as I put the formula, I will get the answer as plus 24. Yes or no? That is the first part. If you can remember simple things, the first part comes very simply. Now can you do the next part? Part number B. 2 minutes you have. Do you want a hint? Oh, I guess everyone is trying. Okay, I guess you are stuck. So what I'll do is I will ask the question in a different way. Probably that way it would be
Sir, minus 24.
Minus 12, sir.
Minus 24.
minus 12 is correct. Minus 12 is correct. Minus 12 is correct. What I'll do is, as I told you, if you would not be able to do it, I will put this question in a different way. So let us keep this question like this and let me bring another question, which I thought that I'll do first, but I just tried. Okay, what happens if I put this question first? And okay, let me put this question first. We'll come to that question, don't worry. This is just one question which probably I thought that I should do it before this one, but then I thought that let me try the other question. If you can do that, I don't have to do this. Let us do this question first. Find the equivalent focal length of a plano convex lens in the following case. Case number one, when the curved surface is silvered. Case number two, when the plane surface is silvered. You can take the radius of curvature as r, and you can take the refractive index as mu. Let us solve this question first, and then we will go on to that question, because the only thing in that question is just the finding the lens ka, that mirror ka focal length wala part. So let us do this question in these two cases, and once we are able to understand how we do this in these two cases, the rest of the question becomes pretty simple. When the curved surface is silvered and when the plane surface is silvered. I'll give you 2 minutes for this. Remember, your answer will come in terms of R and mu. Please remember that, bacha. Your answer will come in terms of R and mu. Shall I do it? So what do I do is I have this as my lens. Let us say this is my lens. Now in first case, this surface is silvered. I have to find the focal length of this lens, and Harshita is giving me an answer. And Harshita, your answer is absolutely correct in the first case. How do I do this? I will put the formula. Which formula I'm going to put? I'm going to put the formula of the lens, the mirror, the combination. 1 by L will be 1 by Fm minus 2 by Fl. Yes or no? Do we remember this formula? I will just put the formula and get the answer. Now here, you must understand the mirror is this mirror, and it is a concave mirror. Yes or no? It is a concave mirror. Do we understand this? Yes or no?
Yes, sir.
What is the focal length of a concave mirror? It is radius of curvature divided by 2. Yes or no? And it is a concave mirror, so it is negative. So I keep all those things in my mind and I write it as minus 2 by r. Anyone understands this?
Sir.
Minus, what is the focal length of this lens? This is a plano convex lens. I found out the focal length of the lens. If you get confused, you can write it here. The focal length of the lens is r upon 2 mu minus 1 with sign convention. Focal length of the mirror is minus r by 2. You can write it on the side. And you just put the values here. Minus 2 upon 2 into mu minus 1 upon r, and that is the answer you are going to get. You are going to get minus r by 2 mu as your focal length. That means it behaves as a concave mirror. Do we understand this?
Yes, sir.
Everyone got this? How I've done this? Now, can you do the second part? When the plane surface is silvered. Plane surface is silver, that means, okay, let me do it with a different color. Let me do it with the blue color. Now I have it like this, and this surface is silvered. The formula is still 1 by f is equal to 1 by fm minus 2 by fl. But now lens remains the same, but the mirror becomes this mirror. Do we understand this? Do we understand this?
Yes, sir.
What is the focal length of this mirror? It is infinity, yes or no? Because this is a plane mirror. So this term actually will get cancelled here. I hope we are able to understand this. Yes or no? No, yes.
Yes, sir. Yes, sir.
Everyone understands this. Now the focal length of the lens, I have written it wrongly here, the formula. It is a plano-convex lens, so it should be r upon mu minus 1, not r upon 2 mu minus 1. Focal length of the lens, plano-convex lens, r upon mu minus 1. I put it in the formula. You will get the focal length of this mirror, and you will get it as minus r upon 2 times mu minus 1, minus sign indicating that it is behaving as a concave mirror. Do we understand this? Yes or no?
Yes, sir.
I intended to do this question before that one, so that once you understand it this, then you should be able to do the other one. Anyways, now you understand how do you find out the focal length of a plano convex lens whose one surface is silvered. We have seen, Harshita, that is correct, but your answer is should be having a negative sign. Do we understand this, beta? Should be having a negative sign because it is behaving as a concave mirror. Do we understand this? Okay. Now let us move to this question. Now the second part of this question, which was the plane surface of the lens is now silvered. We have already found out. They wanted to ask at what distance from the lens will parallel rays converge. So what are they asking in part number B? In part number B, they are
Sir, also
asking the
previous lens.
Focus.
focal length. Yes or no, bacha?
Yes, sir.
Focal length. And we have just now calculated the focal length. When the plane surface of the lens is silvered, you can just put the formula over there and get your answer. What is the answer that you are getting?
Minus 12 centimeters.
Minus 12?
Yes.
Yes or no? So minus 12 is the focal length of this combination. Do we understand this? Then you can move on to
Sir,
the
once
next.
place previous slide.
Okay. What's the problem here? You can just put the formula from here. This one. Got it? Minus r upon 2 times mu minus 1. Got this, bacha?
Okay, sir.
Everyone got this?
Yes, sir.
Yes, sir.
Anyone having any doubt?
No, sir.
Okay, now can you do the next part? Next part of the question. The next part of the question is very simple.
Minus 15 by 2, sir.
Where will the image be formed if the object distance is 20 centimeters? Remember, it is a mirror now. It is a concave mirror now. You should be able to get me the answer. What are you getting, beta? The answer that
Sir.
minus 30 is the answer that I have with me. Are you getting it?
Yes, sir.
That is answer minus 30, my dear friends, then. I'll give you 1 minute. Think about it and get the correct answer sorted in everyone's mind. I'll give you 1 minute. Please think about it and tell me whether you are getting an answer as minus 30 or not. Else I will show how it is to be done. In any case, I will show how it is to be done. But I want you to do it so that you are confident that you will be able to crack this. And that is what I want, that you should have that confidence that you should be able to do this. That's all. That's all I want. That's all I ever want. Well, I'll give you one more question, similar question. If all of you do this, I'll give you one more. Shall I do it now? Okay then. How it is supposed to be done? I have already calculated the focal length at minus 12. Which formula should I apply? The lens or the mirror? If you apply the wrong formula, you will get the wrong answer. I must apply the mirror formula. 1 by V plus 1 by U is 1 by F. I just put the values. 1 by V, I don't know. What is the value of U? It is minus 20. What is the value of the focal length? It is minus 12. You put these values and you will end up with the answer, and I think you are going to get V as minus 30 centimeters. How many of you got this? Please raise your hands. Girls, all of the girls got it. What about the boys? Just one got it. Well done. Now, are you confident that you should be able to get this? Remember the steps. You have to find the focal length of the combination. Then it becomes a mirror, and after that, the things are pretty simple. Let's see. Here comes a question, and I hope that you can do this. This is probably the most difficult question that you can get in the examination hall, whether it is JEE Main or JEE Advanced. Let's see how you are going to tackle this. 2 minutes. Try to do it first and then try to do it quicker. This is the question. It again has everything that we have done so far. So it is a test of everything that we have done till now. A pin is placed 10 centimeter in front of a convex lens of focal length 20 centimeter, made up of material having refractive index of 1.5. The surface of the lens farther away from the pin is silvered and it has a radius of curvature of 22 centimeters. So basically, it is not an equiconvex lens probably. I don't know. Find the position of the final image. Is the image real or is the image virtual? Your time starts now. These questions are supposed to be the very tough ones, the toughest ones probably. But if you understand the concept, my dear friends, this is the question. These are the questions where student gets confused. I hope you are not getting confused. Please try it. I really want you to do it. If you can do good questions like this, you will be confident, super confident about yourself. And I want you to do it. I think I have to do it.
Doing so.
Okay, it looks like it's my duty to do it.
Plus
So
20, sir.
plus
20.
no, plus 20 is not the answer. Answer is minus 11. That is the answer that we're getting. Anyways, we're trying, that is important. So this pin is placed at a distance of 10 centimeters from here. That is given.
Sir,
Yes, beta.
we got the answer.
Congratulations. Well done. Good. First of all, I have to find out the focal length of this combination. How do I find the focal length of this combination? It is silver, so it is 1 by focal length of the mirror minus 2 by focal length of the lens. So 1 by f, let us first do it. So 1 by f will be, what is the focal length of the mirror? Tell me. Radius of curvature is given as 22 centimeters. So what is the focal length of the mirror?
11.
Minus 11.
Minus beta, minus 11. Minus 2 by, what is the focal length of the lens? It is already given as 20, yes or no? Minus 20. From here, I can get the focal length of the mirror. You don't have to find it out in decimals. You can use fractions, because fractions are good. Why do I find out focal length? I will just find out 1 by f, because I need 1 by f only. So I think I will get 1 by f as how much? Minus 210 by 11. Do I get this? Or I have done some mistake? One by f or 20. Okay, they will get added up. T. I think I've made a mistake. It is in centimeters, so I have to convert it into meters. Oh, big mistake. It was in centimeters. I took meters, and that is why the problem. So I will have to check it out. This is the focal length would become in centimeters. So it will come, I think, 110 by 21 centimeters. I think I've made a mistake. Calculating is 21 by 110 will come, yes. Do we get this? You just have to calculate this. Once you get this, you can apply the same formula. 1 by v plus 1 by u is equal to 1 by f. 1 by f is already there. U is given as how much? U is given as
Minus 10 centimeters.
minus 10. Just put it there. And I think the value of v that you are getting from here, I'm not good with calculations, so I would let you calculate. I'll just should tell you the answer that I have, and that is coming as minus 11 centimeters. That is the answer that I have. Is it coming like this? So the only thing that you must be sure about is that you calculate this part correctly, which I always make a mistake. I don't know why. Not good with calculations. So I always make a mistake. Plus ka minus, minus ka plus, and that creates a hell lot of a difference. We got this answer, yes or no? Everyone?
Yes, sir.
Well done, sir. Then I must congratulate you that you have done. If you do questions quickly, I will give you more questions. But if you take so much time, I will not give. Will you do it quickly?
Yes, sir.
Okay, because I have to do some more things here today, and I want to wind this chapter today. So this one, do it fast. Tell me the answer so that I can move ahead. A concave lens, a focal length 20 centimeters, is placed in contact with a plane mirror. How does it act? This question has come in one of the JEEs.
Sir, one show previous slide, sir.
What is there in the previous slide that you want to see? There, see it.
Sir, how did you get minus 21 by 110, sir?
Hmm?
How did you get minus 21 by 110?
You're not getting it? What are you getting?
1 by 110.
1 by 110. Okay, so I might
1 by f equals to minus 1 by 11 minus 2 by minus 20 equals to minus 1 by 11, 110.
let me calculate it. 1 by f is equal to minus 1 by 11 plus 1 by 10 plus 1 by 10 I'm getting. Yes, I've done a mistake. Focal length should be taken as plus 20, no? Focal length of the lens is positive. I've taken is negative. That is a mistake. That is a mistake that I have made. I've taken the focal length as positive. This negative sign got me confused. I've taken the focal length as positive, and that is why my answer was not coming. Now it is correct. Now it is correct.
Yes, sir.
Thanks for pointing out the mistake. Good. I took the focal length as minus 20 and then I calculated it as plus 20. Okay. Can you now do the next one quickly? You
Wait
can
5
do it
seconds,
quick.
sir.
Okay. Okay, here comes the next question. A concave lens of focal length 20 centimeters is placed in contact with a plane mirror. How does it act? We have done convex lenses. This is a question on the concave lens. Convex mirror of focal length 10 centimeter. How did you get convex mirror? Remember, you are also probably doing the same mistake, bacha, that I am doing it. Plus minus ka confusion. This plus minus ka confusion may create a lot of thing. Anyways, you might be right. I don't know. Yes, you are right, probably. The answer is this. Convex mirror of focal length 10 centimeter. Well done. I thought it will be concave.
A, sir.
A, sir. Well done, sir. So how do you do it, sir? So 1 by f will be equal to 1 by focal length of the mirror. Remember, there's a minus sign. Minus 2 by FL. I always do a mistake here. Plus minus. Okay. So 1 by f. What is the focal length of the mirror? The plane mirror. So it does not have any focal length. So that is 1 by infinity, 0.
Infinity.
Minus 2 by focal length of the lens. Concave lens. Does it have positive focal length or negative focal length? It has negative focal length. Yes or no? So the focal length becomes plus 10 centimeters. That means it will behave as a convex mirror of focal length 10 centimeters. We all understand this, yes or no? Girls, do we
Yes, sir.
understand this?
Sir.
Pakka?
Pakka, sir.
Pakka, sir, then There is a question, I think, in your module. If you can do it quickly enough in 2 minutes, we can do that question as well, so that all the questions that I found everywhere, we have done those questions, I think. Okay, do it fast. This is a question taken from your module, and I think it is question number 60. So if you have the module, you can check it from there. This is the question. It comes on your screen now. Now, question number, I don't remember the number. Let me call it question number 3. Find the position of the image. Find the position of the image. It is as simple as this. Let's see who gets this answer quickest. Let's see who gets this answer quickest. Yes, do we have an answer?
Twenty by 7, sir.
20
minus
by
20,
7.
sir.
20 by 7, the answer. Oops, where is the answer? The answer given in the module is minus 20 centimeters. Are you getting this?
Yes, sir.
Yes, sir. Well done, sir. Then everyone got this? 1 by f will be equal to 1 by fm minus 2 by fl. If I put the values 1 by f, focal length of the mirror, plus or minus, convex mirror, plus minus 2 by focal length of the lens, plus or minus, plus, that will give me the focal length of the mirror. What is it coming as focal length of the mirror? What is the focal length of the mirror coming as?
Minus
Minus
10,
10.
sir.
Minus 10, sir. Okay, once you understand this, sir, then I can put it in the formula of 1 by v plus 1 by u is equal to 1 by f. We already know the value of u is minus 20. You know the value of f is minus 10. You should get the value of v, and the value of v is minus 20. That is how you should have solved it. How many of you got this answer? Good. Boys are increasing, but girls are decreasing. I don't know why this happens. If boys can do, girls can't do. If girls can do, boys can't do. Why can't everyone do? I hope I would see a day when what? When all of you would be able to do this. Having said that, there is one thing that is left, and I would ask you to note this down. You can always derive it, but you can take down this as important notes. Take this down in important notes, and the diagram will prove what I wanted to say. So important note number 1, you can draw the diagram and understand, because they can just put the lenses in this fashion, and then I don't want you to get confused. If I have, we have done cutting of the lens, but once we did cutting of the lens, we did not do any question on the cutting of the lens. What happened after cutting? So after cutting, you can put the lens like this. I cut this lens F vertically. If I cut this lens vertically, if the radius of curvature are same on both sides, we have two lenses. The effective focal length of the both lenses is 2f. Yes or no? Now, if you put them together in any fashion, the original lens ka focal length will come. So remember this. Do you understand what is done here? Lens is there. You cut it. If you put it back, the focal length is f. If you put them like this, then also focal length is f. If you put them like this, then also the focal length is f. Do we understand this? Note it down. Important points. They may come as question, straight away question, and that is how they make question difficult in a JEE. They will put those things which no one has done. Noted it down?
Yes, sir.
Last but one of the most important aspect, this one. If I cut it on the principal axis, we have two lenses whose focal length are same, f and f. If I combine them and put the formula of that lens combination 1 by f plus 1 by f is 1 by f1 plus 1 by f2, I will get a new lens whose focal length becomes half. If I put them ulta, one seedha and one ulta, one erect and one inverted, it will behave like a plane mirror. Do we understand this? This is behaving like a plane mirror. Yes or no? Important points. Any one of them can appear as a question in your examination hall. I have given you whatever I have found in all these 20, 25, 40 years, whatever questions have come. I've given you almost everything that has come in all those questions. The only thing that is left is the last thing for this, and that is known as the displacement method. And I have seen a couple of times question coming from this displacement method. And remember, this displacement method is only applicable for convex lenses. Have you heard about this displacement method for convex lenses? This has come multiple times in many exams. Now, this is only applicable for convex lenses. That is the first thing that you must remember. It cannot be applied for concave lens, and you will be doing experiment on this displacement method in your lab. So what happens is, remember, you must be knowing what is a real image. A real image can be obtained on a screen. Yes or no? Do we remember that? Do you remember a real image can be obtained on a screen? Yes or no? Do we know this? A real image can be
Yes,
obtained.
sir. Yes, sir.
Okay. So what happens in this case is, we have a convex lens, we have an object, and the distance of the object is, let us say, u from the lens. Basically, what they do is, how they frame the question is, they will say that there is an object and there is a screen. As soon as you see this question, that means this is a question of displacement method. You have an object and a screen, and the distance between the object and the screen is given as d. The distance between the object and the screen is given as d, and then you are given a convex lens, a converging lens, whose focal length is f. You're given a convex lens and a converging lens whose focal length is f. Now, remember, the first condition is, if your d is greater than 4f, if your d is greater than 4f, what is 4f? F is the focal length of the lens, and 4 is multiplication of 4 f with 4. If f is greater than 4, then there are two possible conditions. There are two possible conditions for this lens to create. There are two conditions, there are two positions for this lens to create real image on the screen. So what will happen is, we will not shift the object, we will not shift the screen, If D is greater than 4F, there are two positions for the lens where you can put the lens and you will get this real image on the screen. Using this principle, we can calculate the focal length of the lens. This method is known as displacement method, and it can only be used to calculate the focal length of a convex lens. Do we understand this?
Yes,
For
sir.
two positions, real image is formed. From this information, if you remember simple points, you should be able to calculate whatever they ask, and I will give you those pointers. So please write those pointers. Have you drawn this diagram? In this diagram, what you have to remember is the distance between the object and the screen is capital D. The focal length of the lens is F. These are the two things that are given to you. What are the two things that are given to you? The two things that are given to you are D and F. So everything that we calculate is in terms of D and F. Do we understand this?
Yes, sir.
Then we can note down some important points. I have told you the first important point. Let me just break it up into anything, into each and everything. Now, if I use the formula 1 by V plus 1 by U, not 1 by U, 1 by V minus 1 by U is equal to 1 by F. This is the lens formula. If I use this lens formula and if I put the value of V as D minus U, I will get a quadratic equation in U. If I solve this, I will get a quadratic equation in U. And remember the solution for this quadratic equation, because this solves everything in this problem. You will get this as the quadratic equation, and you will get two values of U for which a real image can be formed. So this is the quadratic equation, and this is the solution for that quadratic equation. Now, once you remember this equation, everything becomes very simple. If D is less than 4F, your discriminant is negative. There is no position of the lens for which you will get a real image. Now, this thing can be asked in a variety of ways. What is the minimum distance between the object and the image, object and the screen to get a real image? So the minimum distance is 4F. Do we understand this? Yes, Archita, well done. If D is less than 4F, no real image is formed. Remember this. These are the conclusions that we can draw from this displacement method. If D is less than 4F, no real image is formed for whatever position of the lens that we move. If D is equal to 4F, I hope everyone is noting it down. If D is equal to 4F, there is one position for which you will get a real image, and that position is when the discriminant becomes 0, your U becomes D by 2. That means it becomes 4F. Your U will be 4F. If you put this value of U in the value of V, you will also get V as D by 2. So V and U will be equal. Basically, you are placing the object at 2F and you are getting the image at 2F. That is the minimum distance between the object and the image to get a real image. Do we understand this?
Yes, sir.
If D is greater than 4F, then you have two positions of U. You can call one as U1 u1 will be d minus root over d square minus 4fd by 2, or you can have u2 which will be d plus root over d square minus 4fd by 2. So you will get two positions, u1 and u2. Please note these things down. I'll give you 2 minutes to do this.
Done, sir.
Okay, everyone has noted this down?
Yes, sir.
Great. Now, once you get the value of u1, you can get the value of v1 by subtracting u1 from d. You can understand this in terms of a diagram that would basically explain everything, and I'll just put this diagram. So the diagram looks like this. It looks very complicated, but just concentrate on one thing at a time. u1 is the first position of the lens. Once you get the value of u1, you will get the value of v1, and this is the image formed here, I1. Let me color it with a different color so that you understand something. Then the second position is u2, and we have image formed at v2. This is this image that you see, I2. Now there is a very good relation between u1, v1, u2, v2, and I'm going to color it. This u1 is actually equal to your v2, and this v1 is actually equal to your u2. So if you remember this, you can solve some very nice question based on this. So basically what it means is, have I written u2? Basically what it means is, if you get one position for the object and you get one position for the image, if the image position becomes the object position becomes the image position, so it's vice versa. Do we understand vice versa? u1 is the object position in case number 1, v1 is the position of the image in case number 1, u2 is the object position in case number 2, v2 is the image position in case number 2, u1 will actually come same as v1, and v2 will come same as u2. Here there is one more thing that comes into the picture, this x. Now whenever you are going to do this experiment, you are going to move this convex lens. Your object will be fixed, your screen would be fixed. The only thing that you are going to move is your lens. So you will move your lens to one position and you will get the image on the screen. Then you will be moving your lens to the next position to get the image once again. That x you will be moving on a scale, so you can measure the value of that x. You can measure the value of that x, and that x, as you can see here, that x you can calculate The value of this x from the diagram, as you can see, the value of this x is nothing but u2 minus u1. Do we understand this? X is the distance your lens has to move. X is the distance your lens has to move, which is the practical that you are going to do. X is the distance your lens has to move, which is the practical that you are going to do. That will be equal to u2 minus u1. And then, if you understand u2 minus u1, subtract u2 from u1, you will get the value of x in terms of f, or f in terms of x, and that is the result of the experiment that you are going to do. Your f will be equal to d square minus x square by 4d. In the experiment, what you will know is you can find out this d, distance between the object and the screen, and then you can calculate the value of this x. From these two things, you should be able to find out the focal length of the converging lens.
Sir, one show the previous slide.
Yes, here is the previous slide. Once you note everything down, I will write all those things one by one, and probably you can understand them once you give them enough time. Normally, the displacement method is very difficult to understand in the class. Once you do it in the lab, it becomes very simple. Have you noted this down? The different number of ways in which you can remember it, it will become simpler for you to solve questions, because the way questions are framed, they might give you some value and ask you some other value. That is why I am giving you all these things in detail. I've given you the value of u1 in one way. Now I will give you the value of u1 in the other way. The u1, which is equal to v2, can also be found out by d minus x by 2. That u2, which was equal to v1, can be found out by d plus x by 2. So these are different ways in which I am telling you, so that if you can remember these ways, you can solve questions very quickly. The magnification in the first case m1, the magnification in first case m1 will be given by v1 by u1.
Excuse me, sir.
Yes, beta.
Sir, wait for a while. Our monitor has got off.
Okay. Okay. So you can calculate m1 by finding out v1 by u1. Do we understand this? You are there, na? You can calculate m1 by finding out v1 by u1. So if you do v1 by u1,
Another branch did not join the class, sir.
yes, I can't help it now because I have to complete this. They will see the recording. I will continue this class in the next one. So m1 will be equal to d plus x upon d minus x. Do you see this? Yes or no? m2 will be equal to v2 by u2. So if I divide v2 by u2, I will get d minus x upon d plus x. These are the only two things that I had to tell you. So you can note it down. m1 and m2. m1 is d plus x upon d minus x. m2 is d minus x upon d plus x. The last thing, I will revise this in the next class. Don't worry. For the time is getting over. I can't wait and I can't leave it. If I multiply m1 by m2, that is the important thing. m1 by m2 becomes equal to 1. So these are the things that we'll have to remember. I will go through this once again in the next class. because in any ways we'll have to do 1 or 2 questions based on this in the next class. So I'll take this to the next class. I thought that I will be able to complete it, but doesn't matter. There are things that are not in our hand. So if they are not in our hand, man proposes and God disposes, right? Or is it the other way around? Man proposes and God disposes, right? So I was thinking that I would be able to do this. In fact, I wanted to do the JEE Advanced question as well, but time did not permit me. Anyways, we'll continue this in the next class. Happy Diwali, Yashwant. Happy Diwali to everyone in advance, and I'll see you in the class tomorrow. Take care.
Happy
Have a-
Diwali, sir.
Happy Diwali.
Happy
beta.
Diwali, sir.
Happy Diwali. Celebrate it, but don't get in the hangover. Celebrate it, but come back in the next class. I'll see you there. Take care. Have a nice day.
Yes,
Bye bye.
sir. Bye, sir.
Bye, sir.